Hi everyone, I'm Chris Saxon, and today we're going to be seeing how we can use PL/SQL to write simple APIs using Oracle database. Now, I am going to be talking about some things which are coming in a future release, 23C, so just bear in mind some things might change between now and then. Just keep that in mind as we go through this today. So as I said, what we're going to do, we're going to try and build an API, and this is going to be a currency conversion API that we're going to do using PL/SQL. So how this is going to work is we're going to get a list of countries coming in and a price in dollars. I'm going to pass those into our function, and then we need to, for each of those countries, find the local currency and convert the price into that currency. So we'll get some values back out like this. Now, if you look at those final prices, you'll notice they're all kind of like nice prices. There's something 99. They're not just a straightforward currency conversion. After actually doing the conversion, the business wants us to round up to the major unit and then subtract off the minor unit, if there is one. So we get all these something 99 prices as a result. There are also a few unusual currencies we might get as inputs to this. So we're going to have some special handling for them. First up, there's the XXX, which is no currency, and XTS, which is the testing currency. If for some reason we get those as inputs, we're just going to return a whole bunch of nines. Then there's things like the XB currencies, which are related to European bonds. If they turn up for some reason, we're just going to return null. So there's a few currencies we need some special handling for. So at this point, let's just dive in and start writing it. And we'll start with the currency conversion. So this is financial data, right? This is something we want to be sure we get absolutely correct. And it is very likely we're going to reuse this throughout our application. So we've got something, common functionality we're going to reuse. We want to test and make sure is accurate as we can get. How do we do that? We'll create a function. So we'll create a PL/SQL function to do the currency conversion. Then for the API itself, what we're going to do is initialize an array of records, storing the currency code for each current country and the corresponding amount. Now, if you look at this, you might go, where does the country come in? How do we associate the country with this? So what we're going to do is we'll have an array of these countries, and they are actually going to be the indices for the array. So we can access them by the country code. So US, GB, D, so on and so forth. So the caller will pass in this array with the record set to null, and we need to initialize them. So we can do some code that looks a bit like this, which seems okay, right? But if we dig into it, there's a few things which are a bit clunky, a bit messy, things we could do perhaps a little bit better. Let's start off with this while loop. So we've got an array which is indexed by character codes. And unfortunately, to loop through it, we have to do something like this. Yes, it's a bit clunky, it's a bit messy, but it is, or it was, the correct way to do it. And I always have to look this up. I always have to double check how to do it. And it's super easy to make a mistake where you end up with an infinite loop or something like that. So it would be nice if we could simplify it. Next up, the SQL statement, where we actually get the currency codes, exchange rates we've stored, and the corresponding currencies. So seems all right, right? Well, again, there's a couple of performance-related issues here. First up, we've got SQL calling PL/SQL. So these languages have different runtime engines. And every time one calls the other, there's a switch, which, although it's fast, we do that a lot of times, can slow things down. It's probably not a big deal for this statement, but if we really need absolute performance, we'll probably want to look at this. Next, there's a much, much bigger problem with this SQL statement, a much, much bigger performance problem. We've got a loop, and on each iteration, we're only fetching the details for one country. So we're looping through and executing the statement many times, processing one row at a time. If you want slow database code, this is the absolute best way to do it, right? So we probably want to address this, find a faster way to go about it. Finally, we had our case expression to handle our special currencies. And, again, this is okay. But the input expression, the currency code, we have duplicated it. It's not a big deal, but again, it'd be nice if we didn't have to, and we could just state it once. So we'll see how we can address all of these things using Oracle Database 23c. And we'll start off with this lovely little while loop we had here. Before we dive into that, let's just kind of take a diversion and imagine you're in an interview. So it's quite common in interviews where you're asked to solve some kind of basic programming challenge. For example, display for numbers between 0 and 100, display all the multiples of 3 and 5, like a common FizzBuzz type thing. So to do this in PL SQL, we could have our for loop from 0 to 100, and then inside it test whether each value is multiples of those values, and if it is, then display the output. Seems straightforward enough, but the thing here is we are going to check every single number between 0 and 100. But we're only actually outputting about 6 or 7 values in the total range. We're doing a lot of unnecessary work here, potentially. And there kind of wasn't really a way to avoid this previously. Fortunately, in 21c, there is a whole stack of improvements to loop controls, which means we can find better ways to solve this problem. First up, we can now skip through values, not execute the loop body for certain values. Or, we want to change how much we're incrementing by. By default, loops always increase by 1 each time. We've now got the ability to define custom increments. Finally, and probably most interesting and importantly for our API here, we've got much better controls when it comes to looping through arrays. Now, there's a lot of kind of syntax related to these, so rather than just bore you to death with slides, I think it's much better to have a little demo and show how these actually work in practice. So here you can see is my original for loop outputting the numbers from 1 to 100. And what I'm just doing is just showing that I'm really testing all the values in the range, and if it's a multiple of 3 and 5, saying FizzBuzz. So in 21c, we added this syntax, a couple of options we did here. First up, this by clause. So what that means is instead of increase by 1 every time, we'll increase by whatever this value is. So jump up in multiples of 3 here. The when clause allows us to only enter the loop body when that condition is true. So if I run this, we can now see, again, we're outputting FizzBuzz for the multiples of 3 and 5, but we're only executing the loop body for values which correspond to those. Potentially a big saving. It's not a big deal for this little trivial example like this, but if you're doing something slow and expensive in the loop here, could be a big time saver. Now, the mathematicians among you might kind of notice, you can say, well, why didn't I just kind of consolidate Fizz and Buzz and jump up by the product of the two? Well, we can do that as well. I just split them out, just kind of demonstrate there's kind of 2 ways of solving the problem. And again, we can see we've only got those multiples. So that's great if we want to increment by integer values. But what if we want to increase by fractional values, decimals, for example? Well, previously, loop variables always had a data type of PLS integer. Now we can specify custom data types. So, for example, we can increment by fractional values each time. So we're going up by 0.1 on each iteration. And not only can we change the precision of numbers, we can actually pass in a whole bunch of other data types as well. For example, dates. So what I'm doing here is I've got a list of dates. I'm chaining them together, and it will just iterate through those. So we can do dates, and we can also use text values, strings, right? So you can see here, we've got a bunch of country codes, and I'm iterating through them. Sounds like that might be quite useful for our currency conversion API, right? I think that could be come in handy a little bit in a few minutes. Okay, so we've seen different ways we can iterate through things. We've got static values here, and or we incremented by a fixed value each time. What if we've got another type of interview type challenge? We want to display the powers of 2 between 0 or 1 and 100. This time, we're changing how much we're increasing each time. So we can now do this as well with the repeat clause. So what this does is it keeps running this expression until the while clause is not true. So if we run this, we can see now actually get 1, 2, 4, 8, and so on, the powers of 2 up to 100. We can do other forms of interview style challenges, Fibonacci numbers. So we'll start with 0, then with 1, and then we'll keep adding the 2 previous numbers together. and we can see we get those Fibonacci numbers as well. And at this point, if you really wanted to show off, we can actually chain together multiple controls. We can keep chaining these on here. So we can actually display both the powers of 2 and the Fibonacci numbers in one call. So we'll start off here with my Fibonacci numbers, then I'm chaining on, I'm going back to 1, and then doing my powers of 2. So I can do that, and you can see there's my Fibonacci numbers, and then my powers of 2 after that. So that was just kind of like some hopefully nice little examples that show you how these work. At this point, hopefully you're thinking to yourself, well, that's pretty cool, that's pretty neat. As I said, this is the kind of thing that comes up in interviews. Solving arithmetic series is common tests that they give you. But you might be thinking to yourself, well, when am I actually going to use this in real world? I mean, yes, it's nice, help you ace the next interview. Might be useful for things like test scripts and so on. But to be honest, when it comes to actual production code, how often are you going to use these? Probably not that often. Certainly, I can't think of many times when I would have used them. However, if you remember, there was a third thing I was talking about, skipping values, custom increments, but also iterating through arrays. So if you've been a PL/SQL developer for a little while, it's almost certain you've written some code like this to loop through an array. Seems simple enough, but it makes a couple of big important assumptions about the array itself. It must be indexed by integers, and there must be no gaps in the indices. If either of these conditions are not true, we can't do this. And with our array indexed by our country codes, well, it fails both of these tests, right? So that's why we had to have the while loop we had before. So fortunately, in 21C, we've also got some loop controls to help you loop through arrays. So first up, we've got the values of and indices of clauses. If you're familiar with for all bulk processing, we have exactly the same syntax, the same concepts. So values of, look at the values in the array, and those are what the values are for that loop variable. Indices of, will get the indices for that array. There is actually a third option available as well, with pairs of syntax. So notice we now actually have two loop variables, the index and the value. Again, a little simplification feature can be useful to reference each of those separately. So what does that mean? Well, instead of that lovely while loop we had before, we can now simplify it and just use the indices of. Not only is this less code, it's much clearer what you're trying to do, and you're much less likely to make some kind of horrible mistake like an infinite loop. So this is a really cool improvement and really simplifies your code. So we made things a bit better here. Let's move on to that SQL statement. We've improved how we're writing the loop, but we're still executing this query once for each iteration around and processing rows one at a time. As I said, if we wanted slow code, this is the absolute best way to do it. Really, we want the opposite. We want to execute the query once and fetch all the data at the same time. So fortunately, in 21C, we've gotten some improvements that enable us to do this, and that is qualified expressions. Now, this is something which actually came in 18C. So now all PL/SQL array and record types have an implicit constructor associated with them, which makes it easier to initialize them. In 21C, we improve this further, so we can essentially use a loop to initialize an array. To see what I mean by let's have a little example. So in the past, if we want to initialize our array indexed by country codes, we'd probably have to do something like this. Loop through the values, and inside it, then say what the corresponding entry was. With these new qualified expressions, we can essentially flip these operations around. We can push the loop into the type constructor to initialize it all in one go. So we can write something like this. So what we're doing is iterating through those country codes and assigning those to the values in the array. So that's pretty neat, right? Pretty cool. We've defined what we're going to put in the array, but what are the actual indices? How do we control and set what they are? Well, there's a couple of little clauses here that can help and control and define what that is. First up, sequence. What that does is it just assigns integers starting at 1 consecutive up to however many values you get out of the array. So those will be the indices. That will help in a lot of cases, but not here. We want those country codes to be the indices. So instead, we can use the index clause. So we can have a custom expression. Here, it's just the values we're getting out of the loop or that we've defined, or the loop we've defined. As I said, it could be an expression, so we could do things like uppercase, lowercase it, and things like that as well. So this is pretty neat, and we can see this probably would help us like initializing the array before we pass it into our function, so we know which countries we're looking for. But how is this helping us run that SQL statement once, right? Hasn't really addressed that problem here. Well, the really cool thing is we can now actually use a cursor for loop here, right? So we can run our query in this initialization. So that means we execute it once and get all the data. So this can improve performance. Right, so how do we do that? Well, we say whatever our type is, we have our for loop, which runs the query, and we're going to use a column from that query as the index, the country codes. So let me say a great way. So instead of multiple executions, processing one row at a time, we'll have one execution which gets all the data. Pretty neat. Okay, so that's addressed the biggest performance issue we had here. But as I said, there's another potential issue here, and that is with this PL SQL function. As I said, we've got this kind of context switch, which brings up an interesting dilemma. We've got this formula, it's financial data, we want to be absolutely sure it's correct, and we probably want to reuse that logic in other places. We really should use that function. But it slows our query down, and in some cases it might be slow things down too much. There's no clear winner here. Which is more important, code reuse and maintenance or performance? There's no clear winner, and you might have to decide on a case-by-case basis. So we're kind of stuck, right? Well, not anymore. And 21C, we've introduced scalar macros, SQL macros. So what are these and how do they help? Well, SQL macros return an expression, and at pass time, the database resolves that expression, and it becomes part of the SQL statement. Now, macros come in two flavors, table and scalar. As you can probably guess from the name table macros replace a real physical table or a view, subquery, and so on. Scalar macros replace PL SQL functions. So you can use those pretty much everywhere else. It's legal to use a PL SQL function in your query. So the select clause, the where clause, the order by, and so on and so forth. A small version thing to be aware of, SQL macros as a whole were originally slated to be for 21C. Table macros only have been backported to 19C. Scalar macros, you still need to be on 21C to actually use them. So I'm going to be focusing on scalar macros for the rest of this. So that's what SQL macros are. They return an expression. How do we actually create one? Well, it's a bit like creating a PL SQL function. We create our function and add the SQL macro clause to state whether or not it's table or scalar. One of the interesting thing you might have noticed if you're paying close attention is like I'm saying I'm returning a clob, and you're like, what's the deal with that? SQL macros always return text. They always return a string. Okay, and so like, what does that mean? Well, let's take our function to do the exchange rate conversion. To turn this into a macro, we will need to change the return clause, and all we need to do is wrap the formula itself in quotes. So quote it so it becomes text. So we just change it like this. I've changed the name just to make it clear it's a macro, but if I flick backwards and forwards a couple of times, you'll see very little is changing here. So how does this then help in any way? Well, the parameter names in this string are effectively placeholders for the actual values we'll pass when we call this. And at pass time, the database resolves those placeholders with the actual text that you passed. So this is a textual find and replace. It doesn't evaluate those values in any way. To see what I mean by this, I think it really, really helps to look at an example. So if we're going to call our macro in our query like this, so we're going to pass in a bind variable, a column, and a literal. So the database, as part of passing this, it will take the text of that formula and essentially paste it into the SQL statement instead of the function. and then it will do the replacement. And as I said, it is a textual replacement. So literally, we get the bind variable, the column, and the literal in the final SQL statement. Notice it doesn't peek at the value or evaluate these in any single way. The bind variable itself becomes part of the statement. So what does this mean? Well, what this means is we've got our function, so we've got our reusable logic, but it's resolved at parse time. So at runtime, we are running pure SQL. We've got the maintenance benefits of PL SQL functions with the performance benefits of pure SQL. So we can call it wherever we want. And what this means is there will then be no context switch. We don't have that overhead switching back and forth between the engines. It can give good performance benefits. There is a bit more of a fringe benefit as well. So PL SQL functions are essentially a black box to the optimizer. It kind of doesn't really know what's going on there, so we'll quite often guess when it's estimating how many rows it's going to process. Because we've resolved the underlying expression, the optimizer has full or better visibility of it, which increases the odds it'll find a better plan. Doesn't guarantee it, but it does increase the odds. So to kind of recap on that, we had our SQL inside a loop and we're processing one row at a time. We've changed this. So we're using qualified expressions. We execute the query just once and get all the data. Good performance gain. We can gain a little bit more performance beyond that as well by changing our function into a macro, solving that argument, do we have a function and reuse it, or do we rip the logic out and put it in SQL and accept things are going to be harder to test and maintain? So we've made some good improvements there. Let's at last finally move on to our case expression where we're doing the currency code conversions. So as I said, this is a search case expression, and we're checking the same thing each time, the currency code for the current records. And as I said, this is duplicating code, which generally kind of frowned on. So what can we do about this? Well, we could actually simplify this, or we could reference the currency code just once by changing it into a simple case expression. Seems good, right? Why didn't I do that? Well, notice now we've got an implicit equality check for all the values that we had. So our test currency, our invalid currency, our bond currency, we've got to list them all out individually. I'm not sure this is any better than that search case expression we had before, right? So it'd be kind of nice if we could have like best of both worlds, just list the currency code expression once and then have our in list and our like expression and so on and so forth. So good thing is in 23C, we've now got the ability to do this with extended case controls. We've got what we call dangling predicates. So instead of assuming that each when condition or each when branch is equal to whatever the input is, you can specify pretty much any condition you want here. You can say if it's not equal to, if it's in a list, if it's like, if it's greater than, and so on and so forth. So now we can simplify that case expression. So we can just list the currency code once and say which value it's in to get the nines. We can check our bond currencies, return null. If for some reason we haven't got a country code, we can turn 0 and so on and so forth. So not a huge deal, but again, just a nice little simplification feature, which makes your code easier to write, easier to reason about, and so on. One tiny thing to be aware of this. So we can use case expressions in PL SQL and SQL. Currently, this is only available in PL SQL. We do plan to add it into SQL at some point in the hopefully not too distant future as well. All right, so to kind of just review what we did here. This is the code we had before. We had that kind of clunky while loop. We're processing rows one at a time inside for our SQL statements, and slightly messy case expression. We're able to rewrite it to something a bit like this. May not look too much better at first glance, but we've got some good performance gains here. It's probably the big thing here. We are executing the SQL statement once and getting all the data, and we don't have to worry about, silly conditions with our while loop. So we can rewrite the internals of the API and just make it a bit cleaner and easier to reason about. So that's great, but at this point, we're still passing in and out PL SQL, right? There's a good chance any application developers, they don't want to do that. They want the data as JSON. They want to talk JSON. So it's like, can you just convert that all into JSON? Well, the good news is you can. So in 23C, we've now got a simple way to convert from JSON to PL/SQL arrays and objects and back again. If we've got JSON we want to turn into PL/SQL types, we just use JSON value with the array type. And it does this mapping, so the attribute names in the JSON have to match the attribute names in the record and array and so on. And it will map those up and do the conversion for you. So as long as they match, it's super simple. Going back the other way and going from PL/SQL back to JSON is even easier. We just use the JSON constructor like this to do the conversion. So at this point, just kind of show you again how all this works in practice. Let's just have a very quick demo to show them all in together. So there's our country codes in a table, and here's our exchange rates. Here's our original function. Here's our API. We're going to do a conversion, and here we've got it. We're going to loop through and so on and so forth. So this is kind of like the old school way to call it, to initialize the array and iterate it through it afterwards. And if we do that, we can see we've got our values out like that. So now let's change the function into a macro, and I'm going to create a global temporary table. We'll get the JSON and we'll load that into it so we can actually join our query to this in the function. So we're going to see we'll join that there. And so we can do that all in one pass. And now I'll call it passing in JSON. And you see, I'm going to load that into our global temporary table as we start. And you can see there we've got our codes. There's one other thing, one slight difference or addition here. Notice if we pass in an invalid, a country that has no currency code or invalency country, we've handled it automatically. We're already making that 0. And we've converted that data to JSON as well, with just one line of code. You see we've JSON serialized it. There we go. Just do that conversion. Nice and simple. Alrighty then, to finish up, as we've seen, there's lots of things in Oracle Database 23C to help you write better database APIs to process your data. There's a whole stack of stuff with better loops, and I kind of only shown you a little bit of what's there. There's a whole bunch more you can play around with too, so do check that out if you're interested. Probably the thing that will interest many of you, we can use things like qualified expressions to a better array initializations, particularly when it's coming from queries, and SQL macros, particularly scalar macros, resolve that kind of maintenance, reuse versus performance dilemma. Finally, overall, there's just lots of little things, which means we can write less code, which means it's just easier, less for you to do, makes your code easier to reason about. So finish up, all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something. I'm Chris Saxon. I hope to see you again soon. Goodbye.